Two ideal gas thermometers A and B use oxygen and hydrogen respectively. The following observations are made. For the triple point of water, the pressure in thermometer A is 1.25 into 10 to the power 5 pascals and the pressure in thermometer B is 0.2 into 10 to the power 5 pascals. And for the melting point of sulfur, the pressure in thermometer A is 1.797 into 10 to the power 5 pascals and the pressure in thermometer B is 0.287 into 10 to the power 5 pascals. What is the absolute temperature of normal melting point of sulfur as read by thermometer A and B? As we know, the ideal gas law is PV is equals to nRT. Now we know that pressure and temperature are constant. Therefore, P by T is equals to nRV. As moles of oxygen and hydrogen inside the thermometer and the volume occupied by the gases remain constant, P by T would also remain constant. This is the reason for P by T to be constant. The triple point of water is 273.16 Kelvin. The pressure as given is 1.25 into 10 to the power 5 and the pressure for normal melting point of sulfur is also given. So now we put these values in the equation. P1 by T1 is equals to P2 by T2. Now we put in all the values and get T2 as 392.69 Kelvin. For the second one, the pressure in thermometer B for the triple point is given and the pressure of thermometer B for melting point of sulfur is also given. So now we put these values in the equation and we get temperature as the temperature as 391.98 Kelvin. What do you think is the reason behind the slight difference in answers of thermometer A and B? What further procedure is needed in the experiment to reduce the discrepancy between the two readings? The slight difference occurs because the gases used in the thermometer are not ideal gases. To reduce this discrepancy, the experiment should be carried out at low pressure where this behavior of real gases tend to be close to ideal gases.